Hello everyone, welcome to Learn Algebra. Today I'm going to teach you guys indices. In indices, we'll be dealing with some algebraic terms like having x square, x cube, or something like y4 or y12 or y16 or something else like that, where there will be powers, or it is also called index. Now if this is y16, and this 16 is known as exponent, also called as power or index. In fact, it has many names. Now this y will be the base, and whenever we have to do the operations regarding these kind of algebraic terms, there are some specific rules. Those rules are called rules of indices, and in short we just say indices. And in rules of indices, first rule would be something like this: x squared times x5, let's say. Okay, this would be written as x squared can be written as x times x, and then x5 will be x times x times x times x times x. So 1 2 3 4 5 6 7. So altogether there are 7x, so x to the power 7. In fact, this will give us answer x7, but if we try to find the rule, then it could be x2 plus 5. In fact, when the bases are same, these are the bases are same, we can add the indices up when there is multiplication in between them. So when xm times xn, here this base x and another base x is same, so the answer will be x m plus n. The rule is we will simply write the base only once in the answer. Here we multiplied two terms like xm and xn, and then x is the base and they are same, so we'll write the base only once and then add the m and n which are on the top. So this is the answer. In the same way, when we divide this way, it will be x m minus n. For example, x6 divided by x2 will give me x6 minus 2, that is equal to x4. And also x negative m can be always expressed as 1 over xm. This is always true. These are very important rules in indices. This is same like x to the minus 5 can be written as 1 over x5, or x5 can be also written as 1 over x to the power negative 5. So both of them are true. So this is the same rule that we are applying here. And another rule would be x to the power 0. It will be always 1. X to the power 0 or y to the power 0 or any algebraic variable, when 0 is raised to the power of that variable, then the answer will be 1. How do we justify this? Is x over x. It will be always 1, but if we try to do the x over x by this rule, xm divided by xn, then here is 1, here is 1, so 1 minus 1 x0. That's why this and this are equal. That means x0 should be equal to 1. So this is always true. x0 or y0, everything to the power 0 is like dividing itself by itself, so that is of course 1, always 1. And next rule is when any algebraic variable will have some kind of surd form like this. X, let's say 3, and then here 4. Then we can write this as x3 over 4. In general way, x m n this way will give me x m over n. If I try to color code it so that all of you understand, this is the surd, and this will be changed into this division sign. And if this is m, which is on the power of x, this will be on the top or numerator, and this n, which is the order of the surd, or it will be in the denominator like this way. So any surd form can be converted into like this form of indices, and then it can be very much handy if we like to do the operation following the rules of indices. Still, we have some other rules. X, m, n. That is, when there is the layer of power, let's say the m is the index of x, and then there is again another index to the whole of x to the power m, then here is one power m, then there is another power n, so there is multiple layer of power. Then in this case what we do is we'll write the base and we'll times m and n, so this will give me answer, that is x m n. Example will be something like x cube 5 will give me x 3 times 5, that is x to the power 15. Now let's go to solve some problem. Let's write a problem. Problem 1. Okay, and then this would be x 3 y minus 5 minus 3 x 3 y 3y 4. Okay, so this is the problem. We got to solve it. How do you solve it? Is just following those rules. Now here, this negative 3 power is for all the terms or all the algebraic variables that is inside this bracket. Now, so that means x to the power 3 should be also having this, and y to the negative power 5 should be also having this, and x cube, and also the same way this 4 is for everything that is inside this parenthesis. So that means 3 will be having power 4, y will be also having power 4, and if we further use the rule, there is multiple layer of power, so x 3 times negative 3, 3 times negative 3 is negative 9, y negative 5 times negative 3 is positive 15, x cube 3 to the power 4 is 81, and y4. And now here x and x bases are same, so we'll just write base once 9, and then whatever is on the denominator, it will change the sign from the rule. The top one will remain same, so it will be like this, and y top one will remain same, the denominator one will change the sign, and it will be like this. So remaining on the denominator is just 81. Now I'll write over here, so x negative 9 negative 3 will make negative 12, and y will be 11, 81. But now what I want is like I don't want to see these negative signs on the index, so I try to make them positive. And how do I make them positive? Is just by switching the denominator to numerator or numerator to denominator. Since here it is negative on the numerator, I'll just move it to the denominator so that it will be negative. Just I follow this rule: x to the power negative m is xm. So that's all. So y11 will be equal to 81 x12. So this will be my final answer. Thank you very much.